All right, task number 2, graphing. So we talked about in task number 1 what tangent was. It's the ratio of y over x. And if we took the values that we found around our unit circle and we plotted them on our graph, one period would look like this. And so the pattern for one period or one cycle for sine or cosine was the like 0 max, 0 min, 0. But for tangent, it has a negative branch and a positive branch. And it has, for just the parent function, vertical asymptotes at negative pi over 2 and positive pi over 2. And so if we were going to look at this, what is the domain of the parent tangent function? It's not all real numbers. The domain is, in this case, negative pi over 2 is less than or equal, or just less than. It's not equal to because it's an asymptote. X, which is less than pi over 2. And that's just for this section. That's going to happen every pi values. The range, our range is all real numbers because notice it goes down to negative infinity all the way up to positive infinity. And the period, this distance here is pi over 2 plus another pi over 2, so the period is pi. Right, so make sure you get the notes down that you want to get down. I'm going to show you an easier way to graph than putting all these points in. If you elect to do the investigation, maybe you're not even watching this video, they do have you post all those pins. So sketch at least 2 cycles of the graph y equals tangent of theta. So in this graph, we don't just start at 0. So I draw my xy axis like this. And maybe this is negative pi over 2. Here's 0. Here's positive pi over 2. Here's pi. And here is 3 pi over 2. So I just went by a scale of pi over 2 because that's what it looked like on the graph that we saw on the previous slide. And then I'm going to draw in where I know my first vertical asymptotes start. And remember, we said this distance between the 2 vertical asymptotes is pi. So then I want to travel another pi to put in my next set of vertical asymptotes. So here's half a pi plus another half a pi. So I'm going to have another vertical asymptote here. And here's how I graph tangent. I have a point in the middle, halfway between my two vertical asymptotes. Oops, I was having trouble focusing there. Is my point where I show my amplitude. So this is 1. I'm going to put down here -1. I have a point here and a point there. So this is at pi over 4 and negative pi over 4. Thus, these 2 points here are how I'm going to show my stretch. And then I draw in the curve approaching the vertical asymptotes from both sides. So on this way, I come up like this. And towards this asymptote, I go down like that. Now I'm going to do it one more time. Halfway between my 2 vertical asymptotes is my 0. Then halfway between those is my amplitude of 1. And then I draw in my branches approaching the vertical asymptotes on both sides. So if you need to pause and make sure you get this, go ahead and do that. All right, so let's graph something that's not the parent function. So here, I still have an amplitude of 1. Notice I don't have a value in front, but I have a b value of pi over 3. So a couple things that we learned in task number 1. We want to figure out what our period is. So the period is pi over b. So it's going to be pi divided by pi over 3, which really is going to be pi over 1 times 3 over pi. So here's my period is 3 pi. And then remember how we figured out how we had vertical asymptotes. So negative pi over 2b to a positive pi over 2b. That's how we're going to start our cycle and get our scale. So negative pi divided by 2 times pi over 3 to a positive pi divided by 2 times pi over 3. I'm going to show a lot of extra steps on this just so you guys don't get confused, but this is negative pi divided by 2 pi over 3 to a positive pi divided by 2 pi over 3. And then if I want to convert that, I'm going to have negative pi times 3 all over 2 pi to a positive pi times 3 all over 2 pi. So the pi's cancel here, and we get these vertical asymptotes of negative 3/2 to a positive 3/2. Oh, and I actually did this period wrong. This period should be just 3. So go up here. I forgot that these canceled. So this should be a period of 3. And so this makes sense if my vertical asymptotes are negative 1.5 to a positive 1.5. That would be a period of 3. All right. So I'm just going to put in some points here. And then I'm going to draw in my first set of vertical asymptotes. So negative 1.5 to a positive 1.5. So that's a difference of 3 for here. And then I'm going to go a full period over to get another difference of 3 because it says I want 2 cycles. So here's 1, 2, and 3. So I'm over here at 4.5. So I got all my vertical asymptotes in. And then I want to go halfway between 1.5, negative 1.5, and positive 1.5. And over here it's 0, so it's kind of easy. And then halfway between 0 and 1.5 is about 0.75, where I'm going to be showing my amplitude. So right about there, and maybe right about there. And then I'm going to draw my branches in, and then halfway between 1.5 and 4.5 is here at 3, and then I go about 0.75 both ways here to show my amplitude, and I draw my branches in there. All right, so there's a lot of notes on there. So go ahead and pause the video if you need to get those all in. All right, so here's some practice. You might want to have your unit circle for this, so go ahead and pause and see if you can do these on your own. When you come back, we will go through them together. All right, so supposedly you had filled in your tangent values around your unit circle. So up at pi over 2, you know this one was undefined. At 2 pi over 3, I see here's my x and y. And when I do those, I get a negative root 3. And then a tangent of negative pi over 4, I'm going to come down here, negative pi over 4. Here's my two values there. So this should be negative 1. All right, sketching two cycles of the equation y equals tangent of 3 theta. You should have known that b is 3. And even if you're still having trouble graphing, I'm hoping that you were at least able to get that the period was pi over 3. And that would make my vertical asymptotes negative pi over 2 times 3 to a positive pi all over 2 times 3. So my vertical asymptotes are negative pi over 6 to a positive pi over 6. And that helps us give our scale. So we're going by each dash on the graph is going by pi over 6. And we also did not have a stretch on this one. So I'm going to show you two different graphs on this same one. One is if I added a stretch. All right, so let's just say that this is negative pi over 6, and here is positive pi over 6. If you're using graph paper, you can be a lot more accurate with that. If I add another pi over 6 over here, I really get 2 pi over 6, which would be pi over 3. So I'm going to put that down below. And then if we add another pi over 6, that's 3 pi over 6, and hopefully you realize that's pi over 2. And then I draw my vertical asymptotes in. So here is a period of pi over 3, and then 1 pi over 6 plus 2 pi over 6 gives me pi over 3. So here's another distance of pi over 3. So there's my vertical asymptotes. My zeros go right in the middle between my two vertical asymptotes. And then if this is my amplitude has not been changed from 1, then I'm going to have a point halfway between my asymptotes. And it's going to be at positive 1 on this side and negative 1 over here, and then I draw my branches in. Same over here, halfway in between are my amplitude, and I draw in my branches. All right, what if this was y equals 3 tangent of 3 theta. So my vertical asymptotes aren't going to change. My zeros aren't going to change. What's going to change is instead of having this first point here halfway in between being at 1 and negative 1, I'm going to be at 3 and negative 3. So I'm going to put my new point up here and new point down here. And then I'm going to draw it in but highlight it with a different color. So notice how it made it much straighter. That's this picture here. So if I did that over here, halfway in between, I'm going to have a point up here and a point down here at negative 3, and I draw that in, and so it's just a much straighter, stretched out graph. Right. That is it for graphing.